So, good morning. It's great to be here at EdCon. So, over the last couple of days, I've had the opportunity to talk to a bunch of great developers working in native blockchain organizations. And really, one of the recurring themes has been the excitement at the pace of change and growth and adoption we've seen in Ethereum and other blockchain technologies over the last 18 months. And a lot of that has been driven by the by the issuing of tokens, which has obviously allowed organizations to fundraise and also importantly build communities and network effects around their product. So what I want to talk about today is some of the challenges and opportunities of how we continue that pace of growth and adoption over the next 1 to 2 years, in particular as more traditional companies get comfortable with blockchain technology and want to enter the space, and as regulators start to engage more seriously with blockchains and public ledgers. So I want to start by just touching on some of the differences between utility tokens and security tokens. So a utility token, which is largely what we've seen being issued over the last 18 months, entitle the token holder usually to some access to a protocol or to a service. So that they're purchasing this access. And they're not really seen as investments, and as such, the sale and transfer of these types of tokens is not highly regulated. Conversely, security tokens represent some ownership of a real-world off-chain assets, maybe fractional ownership in real estate or in a venture fund, and the people purchasing these types of tokens are really doing so as an investment with some sort of expectation of profit or return. And therefore, the sale and the transfer of these tokens in the secondary markets are regulated in much the same way as traditional securities are regulated, which means broadly highly regulated. So, we've seen how the ERC20 specification or standard has really fueled this growth in the token ecosystem. Allows wallets and exchanges and various other third parties to interact with tokens in a uniform way and fueled that growth and adoption. But for security tokens, there are a couple of areas where ERC20 lacks a little bit of clarity and could do with some improvement. So what are those areas? So there's two key areas we see as needing a little bit more specification. The first is related to transfer restrictions. So, broadly with a ERC20 token, if you have enough balance, you can transfer that token in a peer-to-peer fashion, usually without any restrictions. With security tokens, that logic is much more complex. So maybe it depends on the jurisdiction of the person sending the tokens or the jurisdiction of the person receiving the tokens. It may depend on how long the person has held the tokens before trying to transfer them. Maybe it depends on some token level data, like the total number of token holders and so on. So that logic is much more complex. And ERC20 doesn't really provide any facility to check whether a transfer of tokens is valid on chain without the all you can really do is take a suck it and see approach where you try to execute a transfer transaction, and either it succeeds or it fails, and there's no way of checking up front whether a transfer will be valid or not on chain. So the second gap we think with the ERC20 when it comes to security tokens is around how those tokens are created or destroyed. So so ERC20 doesn't have too much to say about this, and we've seen ICOs and token contracts taking a variety of different approaches. Some initialize total supply at the final number and then transfer tokens out as they're sold. Some initialize total supply at 0 and then mint tokens as they're sold and so on. So that's and when it comes to security tokens, where the token represents some real fractional ownership in a building or a skyscraper or something, the creation and destruction of those tokens is much more important. So what does this standard look like in code? A couple of kind of basic things to point out. One is that the ST20 standard inherits from ERC20. So any ST20 compliant token is also by definition ERC20 compliant. And the next is that it's an interface. So it doesn't say anything about how these functions are implemented. It's obviously similar to ERC20. It's just an interface. So the first function, verify transfer, addresses the first of these issues. So the kind of parameter list looks obviously very similar to transfer and transfer from, and it returns a Boolean, and it allows you to check on-chain, so with a smart contract, for example, whether a transfer would be valid without actually executing that transfer. So a kind of use case or example of where this would be useful is if Alice is trying to buy a security token on a decentralized exchange, that decentralized exchange, before allowing Alice to purchase those tokens, would check the result of verified transfer, probably with a from address of the exchange contract and a to address of Alice and the appropriate amount, and only allow the trade to be executed if it returns true. And this means that when Alice goes to withdraw her tokens, which may be obviously sometime later, like a day later or a week later or something, the exchange has kind of confidence that Alice will be able to withdraw those tokens. So the next part of the standard addresses the kind of second gap I mentioned around how tokens are created or destroyed. And really it just specifies that any increase or decrease to total supply must go through one of the two functions, mint or burn, respectively. And there are the kind of corresponding events for those. So what exactly is a modular security token? If you imagine that you're a venture fund founder and you want to issue a new tokenized fund. So how does that work? You start with a very simple ST20 compliant security token. You then are kind of presented in the Polymath ecosystem with a sort of menu or app store of token functionality represented as modules. So let's say you're going to need some kind of KYC functionality because you want to remain compliant with transfer restrictions. So you grab a KYC module and add that to your token. And you want to do some funding, so you grab some funding modules and add those to your tokens. You then go ahead, you fundraise, you make some investments and so on, and a couple of months later, you realize you want to be able to pay out dividends to your token holders. So you come back to the Polymath ecosystem, grab a dividend module, and add that to your token. So why are we taking this approach? We think it kind of gives a good balance between flexibility and immutability. So it is possible for issuers to provide some immutability guarantees. The issuer can lock down certain categories of modules, like funding categories, which gives investors the kind of usual immutability guarantees people are used to in the blockchain space, but obviously gives them flexibility and helps them future-proof their token against kind of new business requirements or regulatory requirements. So modules in the Polymath system live in the Polymath ecosystem. So if you're a developer and you have a great idea for some functionality that would be useful for security tokens, so maybe some kind of clever way of doing on-chain governance or a clever way of doing continuous dividends or something like that, you can take your idea, implement it in code, wrap it up as a module, and add it to the Polymath ecosystem with a fee, and specify a fee denominated in Poly for that module. Issuers would then see your module in their kind of app store or list of token functionality represented as modules, and then if an issuer adds your module to their token, they would obviously pay you the fee you specified in Poly to do that. So I want to take a very quick look at what a module looks like in code. This is a sort of dummy module. Really just kind of get across the idea that it's easy. If you're a developer or a Solidity developer, it's very easy to wrap up your functionality as a module. So there's a couple of kind of interfaces. There's iModule. that you have to kind of address, and some interfaces which are specific to module types. And there's a little bit of boilerplate code. So all modules are created through factory contracts, and the boilerplate code allows the factory contract to instantiate the specific instance of the module for a security token and configure it appropriately. And then you can just get on and work on your business logic. So here, we're just allowing the issuer to generate tokens arbitrarily. So kind of looking forward, there's a few areas we're keen at Polymath to start to kind of engage with the community on. So we're looking at some of the newer token standards, particularly ERC 777, and how they kind of would work in terms of security tokens. We're really interested in some of the self-sovereign identity standards and how those can be used to improve the KYC process for security tokens, in particular ERC 725. And we're continuing to work on the Polymath protocol, making interactions between modules and security tokens more flexible to give developers more options when building those modules. And then lastly, we'd like so modules have this kind of reputation system linked to which issuers have used which modules and so on. We'd like to improve that, leveraging kind of community involvement in that process. So all of our code is on GitHub, so I encourage you to come and check it out. We're running a public bug bounty at the moment, so if you're a Solidity developer, there's kind of good motivation there to kind of come to the code base and try and find bugs. You can drop me an email at adamdossa@polymath.network if you have any technical questions or any questions at all. I'd be very happy to answer those. And we have a Gitter channel where we hang out, and very happy to kind of discuss any ideas or sort of technical questions you might have. Thank you very much.
Cheers. Thanks, Adam.